Thank you very much, John. Good morning. Thank you for coming and being here very early on a Wednesday morning. Too early probably for some. I want to make this session quite practical, so it'll help if you help me, just be interactive, ask me questions throughout. Give me a sense of, have you used R yourself? Are you an R programmer? Almost everybody. Are you a statistician? Okay, no statistics in this session, no equations, even though Uwe Liger says any presentation about R needs to have an equation. There's none in here. Some pictures. I'm going to try and make it quite hands-on. So if you have a laptop and you want to follow this, the code that I will be demonstrating is actually on GIST, and I'll point you to where that is if you wish. So, I'm Andrie de Vries. I'm with Revolution Analytics. Revolution is the commercial R company, and we have some potential customers here in this audience who we've been familiar with. I joined about 18 months ago when we set up the European office, and in that time I've been on site with probably more than 100 companies all over Europe, and so we have a sense of what it takes to get R into the enterprise. And one of the problems is that people love R and they love CRAN, but the problem is that you have to deal with these people in IT. So how do you do that? How do you get R and CRAN through the firewall? And that's specifically what I want to talk about, because to go through the looking glass or through the firewall, well, you have to deal with a number of things. CRAN is a wonderful resource. It is 5,867 packages or so, all of them fantastic. But IT doesn't like that. And legal doesn't like that, because IT wants to control what's out there. Legal wants to be sure that you are compliant with the licensing conditions of each of these packages. And HR might not like that, right? So even you as the analysts in charge might not like all of CRAN, because maybe it's too much of a burden to train your people in everything that's new. Maybe you just want to choose data table or just apply or deploy R, maybe not both. Maybe you do want to have both, but not anything that's not been vetted. And so the question is, how do you get your IT people or how do you help them to do that? And so here's the first thing. To go through Looking Glass, first thing you come across are Tweedle IT and Tweedle Legal, right? And what do they care about? Well, I've mentioned some of these things before. IT cares about security. You care about your packages being virus checked. You care about your packages being validated. You care about those packages not having malicious code. All of these good things that IT should help you with. And legal cares about license compliance. So that's really difficult to do with 6,000 packages. And even if they agree to do all of that, well, in this age of big data, every IT department is running Hadoop, right? Who's using Hadoop in the organization? It's a few. Okay. So now you have the problem of getting CRAN not just in your machine, not just in the server, but in each node in your cluster, each node in your Hadoop setup. So lots of good reasons why you want to have only a subset of internally approved packages to that. And that is where Minicran comes in. Because in principle, this is not hard. There's very good instructions for creating a complete mirror of CRAN. And in fact, I don't know, maybe 100 organizations out there, most of them universities, are taking a mirror snapshot or a mirror of CRAN every day or every second day, whatever the case might be. And it uses standard infrastructure rsync, if you're familiar with synchronization software. It's really straightforward. But to get just the set you want, that is maybe a little bit harder. And what you want with this internal repository is to behave exactly like CRAN would behave. So you want to use the functions you're familiar with. Available.packages should work. Install.packages should work. All of that. So what IT normally try is they say, okay, I need ggplot. So they go to CRAN, they copy ggplot, to local library and then expect that to work. And of course it doesn't, because, well, why? It's because ggplot depends on a dozen other packages, right? It depends on digest and R color brewer and RCPP, all kinds of good stuff. And these packages might have their own dependencies. So you have this recursive problem of getting everything done. And that's where minicran helps. So what is minicran? Minicran is a package that helps you create a mini version of CRAN inside your repository. Let's get some terminology out of the way first. A repository, in R terms, well, CRAN is repository, so is Bioconductor or RForge. A repository is typically a remote server somewhere with a specific setup of folder structures and index files that allows you, enables you to connect to that and say, I want to install my favorite package from my repository. A library, very confusing, is just a local folder. So you can have a library on your, and in fact you will have that on your R installation. It's just a folder where your installed packages live. And you will have a library for every version of R, typically. And a package, well, you know what a package is. A package is one specific set of functions all neatly bound together. So CRAN mirror, if you want to set up your own CRAN mirror, well, it'll look like this. There'll be a root folder somewhere. That's the top level of your repository. And then there'll be a folder for source, a folder for binaries. In source, all your contributor packages will live. That's purely source code. And in the binaries, there'll be a series of folders for Windows binaries and Mac binaries and their different flavors. And each one of those folders will have a series of subfolders for each version of R, starting with R 1.0 and all the way through to R Devil. And one other thing, there's a file called packages, all capital letters. It's kind of an index file. It's just a text file that tells the repository, this is the list of packages that I have. So if you type install the packages, it goes and reads the packages file, and that's how R knows about what's there. So if you, in the famous words of Ben Goldacre, so to do that, you can do all this by hand, or you can type a few commands. So you list your desired packages, use the data scientist, say I want to use plyr and ggplot and data table and dendextend, very, very famous package by Tull, sitting in the back row. Then you determine the dependencies recursively. So you want to have all the dependencies for import and depends and supports and enhances and linking to. Then you download those files and their binaries, you copy them to the required folders and the folder structure, you create that index file called packages, and then you tell people about that. And in code, we'll get to the code in a second, basically the dependency explosion problem is this. This is imagine you can actually see that. Squint. It's a dependency tree of just 7 popular packages, and the ones I chose were the packages that have the highest number of questions in Stack Overflow. Who's using Stack Overflow? Well, quite a lot of you, fantastic. So I looked at Stack Overflow inside the R tag. These 7 tags that are highest ranked that look like packages are Lattice, XDS, ggplot, datatable, plyr, knitr, and shiny. And if you want to have a recursive table or view of all the packages you need, those 7 packages that I want in my organization suddenly explodes to about 70. And now your problem of installing these packages one by one is an infeasible problem for IT to resolve. So you just gave them minicran and you're done. So, and this is how it works. Just for you, this is the world premiere of minicran. Just for you, last night I uploaded a new version. So it lives on CRAN. It's called minicran. So go well, this morning at 4 o'clock when I woke up with a slight headache, thanks Matt, It was only on CRAN master in Austria. So the mirroring process that happens throughout the day hasn't kicked off yet. So if you want it right now, point to CRAN mirror in Austria, which I'll show you in a minute how to do. If you want it by tomorrow, so it should have propagated through to your favorite CRAN mirror. And then there's a vignette, just type in vignette mini CRAN, which will show you effectively everything I'm showing you here today and a bit more. And this is the code. Library mini CRAN, then you specify a list of packages to download. Maybe you just want a single one, in this case for each. Then I point to my preferred mirror, so you may not want to go to Austria, may want to have a specific mirror for whatever reason, maybe your local university mirror, the closest one, whatever your preference might be. Then you determine the package dependencies. The function for that is package dep. You give it a list of packages you want, and you specify the repository to download from and the type. So that type of package will either be source or binary. And it'll be Windows binary or Mac binary. And finally, the command is make repo. Make repo will make a repository for you. Quick demo. And anybody trying to follow along? Is anybody online? I can give you the gist address. This code is available on gist.github.com. If you search for my name, Andrie, you will find it. So, you'll install the package on CRAN. Let me start a fresh session so there's no trickery involved here. There we go. So by default, my CRAN mirror is a Revolution mirror. And because I just told you that's not going to work right this very second, you probably want to point your mirror to Austria, CRAN at EARL2014, and your repositories, and then install the packages. And because the Windows binary wasn't available on all mirrors this morning, I'm just installing from source. That shouldn't be necessary for you in a couple of hours. I'm installing from source, and there we go, done. I have my library installed, just checking that on my session info. And you can see there, mini CRAN 0.1.0. That is the version that I uploaded last night. So let's imagine, as your first experiment, you want to just pick a single package. And I'm picking CRAN. Somebody who's using time series or dates frequently. So if you're using time series or dates, CRAN is useful for that. I think CRAN is short for chronometer probably, or chronology, or something like that. It helps you with dates. The specifics of the package is not really important right now. What's important is that it neatly illustrates some features that you get in multiple dependencies. So CRAN, can you see that? So it's a bit low on the screen. CRAN, let me try and move that up a little bit. It says Control-Shift+. I think it's just Control+. View. Zoom in. Is that a bit better? Now, what happened to my files if I did that? I've now lost my file browser.
Press the top right. Squares.
There we go, top up, thank you. Ooh, that's what happened now. It seems I've lost my files. No, that's bizarre. Anyway, I can get them back. No, I can't. I'm going to zoom out one level and see what happens.
You have 2 sessions of RStudio?
I have 2 sessions of RStudio. I don't need this one, so I can get rid of this one. In the RStudio, so there we go. There we go. So we've looked at install. We want to have a look at cron. This one here. And then I can move this a little bit up. And what you should see here is the dependencies of cron are a number. It's actually, so just one single package has 15, 16 different dependencies that you need to satisfy to get that to work. Now, we may want to just visualize that. So I have a function, just a helper function called makeDepGraph, which I'm calling. And then the depgraph draws a dependency graph using the package igraph, which makes very neat packages. And I see Andy. Welcome, Andy. Everything I know about igraph is thanks to Andy, because he helped me out when I wanted to get started. So with a bit of luck, you'll be able to see that. Ooh, that's not nice, isn't it? This is what happens if you zoom in too much, I guess. Let's see. There we go. Plot that again. Now, the interesting thing about igraph is igraph plots using some randomness. If there's no predetermined way, or there's a random seed that gets set by igraph. And so when you plot this yourself, you will notice every time you plot it, it'll look completely different. So if I plot it again, you can see that the layout of the graph changes. For example, lattices are now at the bottom left. If I do that again, it's all over the show. But so I set a seed in the code. If you wonder what the seed is that I said, that's why I do that. Just so the randomness goes away and I control the randomness, so I get the same graphic every time. What's important here is, and unfortunately, due to the unique way everything scales, you can't see the legend. But we're looking at package cron here. Cron has a suggestion for two different packages. That's what the grey line means. So in the help for cron, there are examples of using cron with ggplot and with the package scales. So to install cron in such a way that you can actually guaranteed to read all the help files from cron, you need to install ggplot and scales. But to do that, you need to install all their dependencies. So the red lines are import dependencies. And then something else is interesting. You notice that reshape2 and plyr both depend on RCPP, C++ package. And if you want to know about that, ask Rumar. He's the one that's walking around with, don't panic, ask me about RCPP 11. He's just outside. And so RCPP is a binary package. And so these packages, plyr, both imports RCPP and links to those binaries, so the DLLs. So that's what the black lines mean. The blue line is interesting. This is an enhances dependency. That means that it's an optional dependency. There'll be some examples in cron that uses zoo functionality. And if you have it, then there's something better, something enhanced about it. But if you don't have it, then that's perfectly fine. So this is the recursive dependency tree for a very simple package. And here's where so you can see the explosion that IT needs to get satisfied. And if you do want to do something a little bit more complicated, I can do something just for multiple packages. It'll do exactly the same thing and just scroll through that very quickly. So let's say you've been to this conference, and yesterday you would have heard everything about data table, dplyr, ggviz, and tidyr, and maybe ggplot too. The package dependencies for that, just those 4-5 packages goes to 77 packages that you need to go and satisfy IT with. Now, the interesting thing the reason you're here is because you want to know, okay, I know what the dependencies are, how do I make a repository? And that's very straightforward. Start again. Just 2 packages because so this is going to download from CRAN a whole number of packages. I don't want to do this 77 times. And so I tell it I want to have a local CRAN in a local folder. Just my user folder, tilde dash, the Unix terminology for my home folder, local CRAN repo. That's just a file path to my local machine. Create a folder there. I'd say I want to make a repo with just type source, and there it goes. It's now downloading all my files, downloading all the dependencies, creates the package file, and that is really going to be it. Except for one thing, you have to tell people how to use this, where to find it. So make it stick. And while that's running, it'll run for just a second more. Ooh, there we go. Here's how you refer to a URI, Universal Resource Indicator, on a local machine. So if IT gives you a web server, then that's fine. They give you the URL, and that'll be http:// in the way you normally know it. But if it's a file, what I learned recently is you refer to a file using file : //. There are 3 slashes there. So it'll look like this. You'll install packages, for example, from my local file. So you'll just use repos = file and your path to the file. Very straightforward. And if you really want to make it stick, you put that repos location in your options, using options repos = blah, or in your R profile. And then if it's in the R profile for every user in your organization, that's really all that's required, because at startup time, it'll read the options, install from there, and you're done. I think I have 2 minutes left. Ask me about reproducibility over lunch or over tea. What we're doing at Revolution is working on the problem of reproducible research. So we all know that CRAN is this fantastically vibrant source, but packages change almost every day. So it's a problem for organizations to say, I want to have a specific snapshot of CRAN at a specific date, right? We're working on that. There's going to be a package called RRT, the Reproducible R Toolkit, and there is going to be a service called MRAN, the Managed CRAN Service. This package is on GitHub at the moment. If you go to GitHub Revolution Analytics, you'll find it, RRT. It's very early stage dev. I was hoping to give you a sneak preview of it today, but that'll have to wait for just a few weeks more. And the way it works is that we will be taking, and we are taking, daily snapshots of CRAN onto a different server that will probably be called something like MRAN, for managed R archive network. And you will be able to point to a specific date and say, I want to install packages from CRAN as at a specific date. And that we think of it as like CRAN time machine. You'll be able to roll back and roll forward as if you had a time machine. And because there's a server-side component to this, it's very lightweight in the client. It's going to be very easy to use. So in conclusion, if you want to go through the looking glass and take part in the feast that's there, I think these 2 things will help you. Mini-CRAN is the first thing that will help you. And I think when we announced RRT and MRAN, that'll be the second part of the solution.